Part 3, Trigonometry Review. Well, in this review, we're also going to be taking a look at Pythagorean theorem as well. If you forgot Pythagorean theorem works on the premise if you know two sides of a right triangle is a triangle that has a right angle in it, then you can always find the third, with one leg being squared plus the other leg being squared equals the hypotenuse squared, okay? Now, the other thing we're going to need when we do this is our trigonometric identities. And there are 3 of them. Now, if you're taking Math Course 2 right now, you haven't seen this yet. If you have, let's review it. Sine, S stands for sine, and you find that by taking the opposite side of the triangle divided by the hypotenuse. So, ka, toa is the mnemonic, the acronym that helps remember the trigonometric ratios, the trigonometric identities. The ka stands for cosine. Well, cosine, which, by the way, sine is abbreviated sin. Cosine is abbreviated cos or cos on your calculator, and that's equal to the adjacent side of the triangle divided by hypotenuse. T stands for tangent, which is abbreviated tan, and that's equal to the opposite side over the adjacent side. So, okay, now let's look at this right here. This is angle theta right here. That little symbol that you see right there it looks like a 0 with a line through it, that is the Greek letter theta. Theta is an angle measurement. This is an angle variable. Okay, so we don't use, like geometry, we don't use angle ABC or angle MFDQ. We don't use letters of the alphabet like you did in Math Course 2 geometry. No, we use Greek letters to stand for a lot of variables. So the Greek letter theta will stand for an angle measurement. Now, this is always the hypotenuse. The hypotenuse is easy to identify because it's always opposite the right angle. It's the longest side. You can't miss it. Now, the opposite side, if this is my angle, the opposite side is the side all the way opposite. So this would be the opposite side. Okay, now the word adjacent means next to. So you can see side B is next to the angle. Okay, so that's the adjacent side. Now, if I used another angle, say I used another angle like angle phi, which is also a 0, but it has a vertical slash through it. This is angle phi. Well, you can see things are a bit different now because side B is now the opposite side of angle phi, and side A is now adjacent to side phi. So keep that in mind. Whatever angle you use, the sides are going to be relative to that angle. If I use the top angle, this is the opposite side, and this is the adjacent side. If I use the bottom angle, right here, this is the opposite side, this is the adjacent side. Okay, so know what angle you're working with because the sides are relative to that. Okay, so with that said, let's go ahead and begin. Number 12, find C if given A and B. Well, okay, so find one side of the triangle if given the other two. Well, that's easy, that's Pythagorean theorem. So what I'm gonna do is I'm going to use my Pythagorean theorem. So I'm gonna write down, now I'm gonna write it down a little backwards. Instead of writing A squared plus B squared equals C squared, I'm gonna write it as C squared equals A squared plus B squared. I'm gonna write it like that. So C squared equals A squared plus B squared. Now I'm solving for C, so to do that, I gotta get rid of the squared. Well, the opposite of a square is to square root. Now in a math class, you are taught to take the plus and minus roots when you're doing a square root. In a physics class, I'm not too concerned about that because many times the value you're taking the square root of stands for a distance, and distance can't be negative. okay? Sometimes it stands for time. Time also can't be negative. So certain physical quantities just can't be negative, so we don't worry about plus and minus roots in a physics class. But we're going to take the answer to be the square root of a squared plus b squared. Number 13. Find a if given c and b. So we have c squared equals a squared plus b squared. Now, in order to solve for a, you first have to get rid of b squared. How do we do that? Subtract it. Then you have to square root to get rid of that squared. So first step, let's go ahead and subtract your b squared. And if we do that, we get a squared equals c squared minus b squared. Then you can take the square root of both sides, and we get a equals the square root of c squared minus b squared. Okay, now what if we're looking for a side, but we're given another side and an angle? Well, anytime an angle is involved, now we have to use right triangle trigonometry, okay? In other words, we have to use our sine, cosine, or tangent ratios. Now, which one do we use? Completely depends on the information given. So for instance, I'm trying to find a if given c and theta. So what is side A? Side A is the opposite side of theta, okay? And side C is the hypotenuse. So I look back at my mnemonic here, opposite and hypotenuse. What's the only ratio that has opposite and hypotenuse? That would be sine. So I'm going to write the sine of theta, the sine of the angle, equals the opposite side, which is A, over the hypotenuse, which is C. Now I'm trying to solve for A. I'm trying to find A. So how do I find A? Notice I have A divided by C. So in order to find A, I need to get rid of C. How do I do that? Let's multiply both sides by C. And A would be equal to C times the sine of theta. Find B if given A and theta. So what is B? Well, B, remember, B is the side next to theta, so B is the adjacent side. A is the opposite side. And then theta is the angle. So what's the only trig ratio that involves opposite and adjacent? That would be tangent. You can see that over here. Therefore, I would write tangent of theta equals the opposite side, which is A, over the adjacent side, which is B. Okay, now, we're going to go over this a little bit more in our algebra review, but a nice little shortcut. If you're solving for the numerator, you have to divide by the denominator. But if you're solving for the denominator, there's a nice little shortcut that happens. Let me set up that shortcut for you so it makes sense. If I write that as two ratios equal to each other, and then I do my cross multiply, then I get A times 1 is A equals B times tangent of theta. And if I divide by tangent of theta to get B by itself, I get B, and I'll actually write this here next to this, I get B equals A over tangent of theta. Now, if you look what really happened, B and tan theta have just swapped spaces. Okay, that is the shortcut that we can do. It's called the switcheroo. So the way I would apply the switcheroo in terms of a shortcut, okay, I call it the switcheroo. I don't know what anyone else calls it, but if I have tan theta equals A over B, and I'm solving for the denominator, then just simply switch it out with the other side of the equal sign, and we get B equals A over tangent theta. You can see how quick that is, as opposed to doing all these extra steps. Okay, so when I can show you some shortcuts along the way, I will. Number 16, find C if given B and theta. Well, side C is the hypotenuse. B is the adjacent side. Well, the only trig ratio that goes with adjacent side and hypotenuse would be cosine. So I'm going to write the cosine of the angle equals the adjacent side, which is B, over the hypotenuse, which is C. Now you're looking for C, find C, and we just got done saying if you're trying to find the denominator, then simply switch it out, right? Switch a root. So this becomes C equals B over the cosine of the angle. Number 17, find theta if given B and C. Well, B is the adjacent side. Okay, C is the hypotenuse. Okay, and I'm going to start with cosine of theta equals B adjacent over C hypotenuse. The problem is, how do we solve for the angle? Well, the way we do this is we use what are called inverse trig functions. The inverse of a cosine is called the arc cosine. Okay? You see this symbol cosine to the -1? That is the arc cosine. Sometimes it's called inverse cosine. So we're going to take the arc cosine of both sides. So this would be, if I were to write this again, cosine of theta equals, and I'll just spread it out, B over C. It's taking the arc cosine of the left side of the equation and then the arc cosine of the right side of the equation. Now, the arc cosine cancels with the cosine, leaving you with theta, and I would put that in my calculator if I knew the values of B and C. So the angle is going to be the arc or inverse cosine of B divided by C, which is adjacent over hypotenuse. Okay, now in the last few questions, okay, we are asked to try and find the values. Okay, find the actual values. Okay, so, wait, sorry, not quite yet. Number 18, find theta if given A and B. Okay, almost missed this one. So A is the opposite side, B is the adjacent side. The trig function that goes with opposite and adjacent is tangent. So I'm going to go tan theta equals opposite A over adjacent B. Well, how did we do this just last time? Well, we're going to spread this out just a little bit. Okay, and we're going to take the arc tangent this time. We did arc cosine last time because we were trying to get rid of cosine. Now we're trying to get rid of tangent. So we're going to take the arc tangent of both sides. Arc tangent cancels with the tangent, leaving you with angle theta equals the arc tangent of the opposite side A over the adjacent side B. Okay, 19, 20, and 21 are just basically solving problems with actual variables. Okay, so the first one says, you got A and C, what's B? Well, that's a Pythagorean theorem problem. So A squared plus B squared equals C squared. How do we know it's a Pythagorean theorem problem? Because it only involves the sides, no angles. Okay, now I'm solving for B. In order to do that, I'm going to need to subtract A squared first. Okay, and I get B squared equals C squared minus A squared. Now, to solve for B, I have to square root both sides. And now I've got B solved for. B is the square root of C squared minus A squared. But, now you plug in. What was C? It was 7 squared minus, what was A? 2 squared. 7 squared would be 49 minus 2 squared is 4, would be the square root of 45. Okay, now in a math class, you learn how to, what's called rationalizing the, and simplifying the root. Well, 45 could actually be split up into the square root of 9 times 5, which could be split up into the square root of 9 times the square root of 5. And we know that the square root of 9 is 3. So we could write this as 3 times the square root of 5. That's the exact answer. The decimal approximation would be putting that in a calculator and getting a value for 3 times the square root of 5, and it's about 6.7. Okay, now what if the hypotenuse was 10, angle theta is 60, and we're looking for b, which is the adjacent side? Well, again, I'm looking for a trig function that has adjacent and hypotenuse. That would be cosine. So I take the cosine of my given angle, 60, equals adjacent, what I'm looking for, b, over hypotenuse, 10. Now I have to solve for b. In order to solve for b, I have to get rid of the 10 in the denominator. So the opposite of dividing by 10 would be to multiply by 10. b equals 10 times the cosine of 60. If you put that in your calculator, the cosine of 60 is 1/2, so 10 times 1/2 would be 5. In number 21, we have the opposite side is 12, angle theta is 30. What is the adjacent side, b? Well, opposite and adjacent, that trig function would be tangent. So we're going to go tangent of the angle present, 30 degrees, equals opposite, that's 12, a is 12, opposite, over b, what we're looking for. Okay, now remember our trick. If we're solving for the denominator, what does it do? It switches out with the other side. This becomes b equals 12 divided by the tangent of 30. So b would be approximately about 20.8.